suspending, say, one law of logic, like A equals B, C, then A, if you just suspend that it would work.
Well, yes, that's more or less what we do, but we suspend an assumption. We suspend an assumption that we are able to say things like, this is in either this or that condition, when you haven't made any observation yet. And then we can continue to think straightforwardly, and it's the most efficient way of doing it as far as we know. There might be another way, by suspending some particular rule of reasoning and keep the old assumptions, but I don't know a particular way. And I'm just used to the way everybody else does it, which is to change the statement. We have a different statement. I'll just make words which won't mean anything to most, but we're going to say things like, a particle has an amplitude to be in this condition or that condition and so on. Not a chance or a probability or a reality of being in this condition, but another quality. And we would work with these so-called amplitudes and tell you how to combine them. So in the end, from this reasoning, you can predict what the probabilities will be. But this system of reasoning works, but we don't understand it any deeper than that this is a system that can replace the old system, but that works. Well, I don't know what else to say about it. It's very discomforting because it's so easy, it's so hard to believe that a simple-minded idea like the chicken in the icebox, that you can't say either there's chicken in the icebox or there's not chicken in the icebox until you open the door and look at the chicken, that you can't even say that there are these two alternatives or you get into trouble, is a kind of shock. And the shock keeps coming back. And no doubt, because we're all human, we're always sort of falling every once in a while. And I may well have said something about states or something was incorrect, which is sometimes fall off the wagon when trying to reason. But I'll show you the kind of reasoning that is done, the type of assumption that is made, and the system for computing the probabilities. But you'll be very dissatisfied by all that, because it all looks so crazy and abstract and mathematical and dopey, and you don't know why it works. And you say, well, wait, why? Same question. Why is it going to be this? We can't answer. Well, I mean, but I can tell you what the machinery is that we do use to figure out the probabilities. But the machinery wouldn't help to understand this.
I mean, there could very well be that there is a complex world you're entering, in which the common ways just don't work anymore.
That's what we think it is, actually. That's what I think it is.
Is part of the differentiation between the macro world and micro world that, for instance, there are chickens or not chickens in the icebox, which is a different thing than the probabilistic nature is what I'm getting a feeling about atomic phenomena.
Well, strictly, it's like this. When a thing is as big as a chicken or an icebox, since I can find out what's in the icebox by tapping it, by listening to the vibrations, by weighing the icebox and so on, there's all a situation that's so large. A chicken is so many atoms, it's so big, and it's light shining off it. It's like this bulb, which is emitting photons in all directions. It's already made billions of copies of certain information, whether it's in or it's not. So that idea that we can't tell for a chicken is really an extreme. It's like saying, after I made thousands of these copies, I can't say that this is either red or green. What kind of a nervous, why are you so nervous? I could tell by looking at any one box. It's okay, but in a very delicate situation where I only have two boxes and I haven't amplified it yet, I can't say. So it's before you amplify information that you have to be careful. And you say it's the micro world. It's strictly, yes, it's the micro world, but the macro world we understand as being made out of micros. And so it's technically true of the larger world, but it's harder to get the situation because you have to be very delicate.
So,
in other words, yeah.
It's not because of the probabilistic nature, let's just say of nature playing dice or however you want to that actually exists in a sense, if one's allowed to actually exist in that thing. In other words, I no longer have a need to say that nature has, it's free of this box. I mean, all of them in this box or that box, but I can see 3, 4 kind of probabilities happening. It just feels okay at that level in a certain sense to
when
see it as a probability rather than, as a 1 or 0 thing.
It's not just probability. It isn't just probability that gives us our difficulty. We've discussed probability earlier, and there's a probability in classical physics if you don't know the details well enough.